Hi everyone, can you hear me? It's all good, yeah. Having a good time so far, enjoying the conference? Yeah, good, good. So, for those of you who don't know me, and if you weren't in my talk earlier this morning, my name's Adam. I originally come from the UK. My family's all Polish, so my mum's Polish, my dad was half Polish, so I actually have family very near to Łódź, and I've been here a few times, so it's good to be back, and it's good to be back at DevConf as well. So I'm going to talk about build systems today. This is a very different talk to the one I gave this morning, if you came to that one. I'm going to forget all about business rules and domains and service boundaries and that kind of thing. And I'm going to look at tools, right? So just the fun stuff. And ultimately, if you actually like computers, and hopefully this is a talk for you. Has anyone heard this saying before? Do one thing and do it well. Couple of hands going up, right? So I'm sure that a few of you know that this comes from the UNIX philosophy. This is an extract from the UNIX philosophy. Has everyone heard of UNIX? Has everyone who's heard of UNIX? It's pretty much everyone. Okay, so you know it's an operating system that was developed in the late 60s at Bell Labs. And the UNIX philosophy was originated by a guy called Ken Thompson, who actually wrote the original version of UNIX. It was written down by a guy called Doug McIlroy, who worked with him at Bell Systems. And the original is actually very long. It's actually a very long piece of text. But in 1978, he wrote it down, and he summarized it later as this. He said the essence of the UNIX philosophy is to write programs that do one thing and do it well, to write programs that work together, and to handle text streams, because that is a universal interface. So I'm working on a Mac, and a Mac is a Unix-like system, right? Mac OS is not Unix, but it is Unix-like. So it comes with all the standard Unix tools out of the box. So if you're familiar with Unix, you can come to a Mac OS and go to the terminal and be fairly at home. So I can actually show you some of these Unix programs. So if I switch to the terminal like this, let's just get rid of that for the moment. So, who knows what ls does? ls, right, most of you. ls is, all it does is it lists directory contents, okay? Very, very simple. That's actually all it does, right? It does one thing and it does it well. It does have options. You can do ls minus l, for instance, ls minus l to list stuff in more detail. So here you've got the file permissions and the owner and the group, and you've got the file size, which is a bit difficult to read because it's just like a string of digits, but you can do things like add an H, and then it says, you know, this is 90 meg. But ultimately, all these options are just centered around listing directory contents. That's really all it does. So it's very simple. Now, it is designed to work together with other programs in that it uses something called the POSIX standard. So that's I've forgotten an acronym now, it doesn't matter. Oh, Portable Operating System Interface. And one part of that is the standard stream. So you have standard input, which is a program's input. You have standard output, which is a program's output. And you have another thing called standard error, which is a bit misleading in its name. It's for diagnostics and error messages. I sometimes think of it as standard commentary. It's like a program has a standard input for its input, a standard output for its output, and this kind of other thing for comments like diagnostics and error messages and that kind of stuff. So ls writes its output to standard output. And because of that, I can pipe the standard output to another command. So there is a command called sort, for example, and it does what you might think. It takes lines of text and it sorts them. So I can pipe the standard output of ls into the standard input of sort using this pipe symbol, and I can reverse the sort order using a -r flag, and there we are, we get the directory contents listed in reverse order. Now you might think, well, the thing is that when I run ls, it's not a file per line, it's a file per column, and I was actually scratching my head wondering about this, like how does sort actually work on that? Well, ls is actually clever enough to realize that if the standard output is going to a console, it does it in columns. But if standard output is not a console, anything else but a console, like going to the standard input of another command, it does it with a file per line. Like it's actually as if you run the -1 option, which means one file per line. So when I do -l, when I do that, it's like you're running -1, okay? And I'll do it in reverse order so it actually does something, and that's why it works. Let's have a look at another command. So cat, anyone knows what cat does? Prints files, right? List file contents. I used to think it stood for catalog, like, because it just shows you what's inside the file. It actually stands for, there's another Unix command called man, which shows you the manual for a command. That's all it does. And if I do man cat, it actually stands for concatenate, right? It's actually designed to concatenate files together. It's got this very suspicious word in here, and, suggesting it does two things and not one. But really, all it does is concatenate files. You can use it for printing files by concatenating a file with nothing else. Right? So if I concatenate hi with nothing else, I just get the contents of hi. So you can effectively use it to print the contents of a file. But if I join it with another file, so I've got hi2 here, if I concatenate hi1 with hi2, then I get the contents of both files. That's actually what it's designed to do, just concatenating files. But because it uses a POSIX standard and the standard out, you can use it for listing the contents of a file. So I can then pipe that to another command. I can do something like sort to get all the highs at the beginning. I can then sort also writes the standard output, so I can pipe that to another command. I can use something called sed, which is a stream editor. And what this does is it applies a regular expression to a stream of text and outputs the result of that regular expression. So I can do something like substitute hi for hello, and then I get a bunch of hellos. And if I just want to pick out just the hellos, I can do something like grep. Grep is global regular expression print. And grep applies a regular expression to a line of text, and if it matches that regular expression, it returns that line of text. So it's kind of like a filter, if you like. So I can say grep hello, and I only get the hellos. Now I can swap the order of these commands, right? Because they're all working in the same way. It's not very efficient to do grep and sed well, it's not very efficient to do sort before the grep because the grep reduces the number of lines. It's actually more efficient to do something like grep the highs out first, then you could do something like change hi to hello, and then for the sake of it, we'll just sort, and let's do it in reverse order for fun. And it still works, right? So you can swap the order around depending on what you're trying to do. So these are very powerful commands, and believe me, like this is a really, really simple example, but if you know someone who's really, really familiar with the Unix command line, it is mind-boggling what they can do with these commands. Right? I've watched people at a Unix terminal or a Unix-like terminal using grep and sed and all kinds of other things to do really, really amazingly powerful things. So where's my presentation gone? Here. So take a moment to look at the dates here, right? 1971, 1973, 74, and 73. These tools have been around since most of us were born, right? In fact, that one's been around even since before I was born. So that shows you how old it is. They've never been replaced, right? Why haven't they been replaced? Well, why isn't there some great new version of sort or cat or something else? Well, because they've always never tried to do more than one thing. Right? They concentrate on doing one thing and doing it well. Concatenating files, sorting text, editing text, searching text, efficiently and without unnecessary complexity. And what that leads to is several properties. So first of all, simplicity. For new users and experts, they're straightforward to use without having to look up options or syntax. As I said, they do have options, but the basic usage covers 98% of the use cases, right? So they do have lots of options within them if you want them, but basically they are very simple at heart. Compatibility, they adhere to the POSIX standard. Ubiquity, they're available on all Unix and Unix-like systems. So if you've got a Mac, if you're running a Linux, there's even sort of versions of them on Windows, but any kind of Unix-like system will have these tools. Efficiency, they're very fast, they have a low overhead. They've remained really stable over the years, which means there's no learning curve when you're switching between versions, right? They've just remained stable over the years. And they're very mature, well-tested, well-optimized. They're very predictable behaviors, which is critical for sysadmin tasks. And they're so simple and effective that really their continued relevance in Unix-like operating systems is kind of ensured, right? They adhere to this philosophy of doing one thing and doing it well, making them really timeless in the Unix toolset. They've been around for 50 odd years or more, and I will predict that they're going to be around for another 50 years. So I hear you say, great, what does this all have to do with tool chains? Well, in order to understand that, I'd like to take you on a little journey I've had through tool chains over the years. So in the 80s, I used to play with 8-bit computers and 16-bit computers. I used to do a lot of programming, mainly writing games. When I found myself in the field of work, I wasn't doing that. I was actually working in a finance job, and I did lots of work in Excel. Okay, so playing with numbers and doing all kinds of like pretty dull accounting stuff. Only one day, I found this button up here called Record Macro. So I thought, okay, well, I wonder what that does. So I pressed it. I did some spreadsheet operations, and this stuff popped up, right? And I thought, I recognize this. Right? This reminds me a bit of my 8-bit and 16-bit years in the 80s. So I played with it for a while, and I got to know this language. Does anyone here use VBA? Excel VBA? Oh, wow, it's actually more than I thought. It's all right, isn't it? But it's not, not the best language in the world. However, this was the start of my programming career. Okay, I actually did a lot of work in Excel VBA. I actually automated jobs. I automated my own job. I automated someone else's job. And I was loving this because I was getting paid to do something which used to be my hobby. It was really, really good. After a while, I graduated to Visual Basic. So this is not VB.NET. This is the VB. I think I started on VB4 maybe, and then VB5 and VB6, which was the last version. And here you could actually build executables, you could build GUIs and things. You were freed from the constraints of Excel. So I spent a lot of time working on that. Then in 2002, .NET came along, and this is where I still spend a lot of my time now. I'm on Mac, so I don't use Visual Studio anymore much, but I still spend a lot of time in .NET. And over the years, I learned about things like source control and testing and continuous integration, and a really, really novel idea, which was teamwork. Because at the beginning, I was kind of acting like a lone hero. I was just writing code directly for users on my own, and they loved it, and I was having a great time. But around this kind of time, when I switched to .NET, I actually joined a proper development team, and I had to work with other developers. And it's at that time I learned the value of working together and the tooling choices that you have to make. Does anyone remember this? Right-click deploy. Right? There was a lot of fuss made about this when it was released, and Microsoft announced it on a big stage. I can't remember which conference it was, and there was a lot of discussion on Twitter or X or whatever it's called this month, and this allowed you to deploy from Visual Studio, and that's probably okay for your family website, right? Which is what is shown in this example. But when you're working in a team and you're working on possibly mission-critical applications, you want to have some kind of reproducible build. You don't want to be relying on that one developer who happens to have the machine set up just right to be able to deploy. If they're off sick that day, you still want to be able to deploy. So we looked at things like continuous integration servers. We use a lot of different things like cruise control.NET, Atlassian Bamboo. I end up spending most of my time in TeamCity, which is a very fully featured CI system. But of course, we don't just want to build the code, we want to test it too, right? There's loads of tests going along in this screenshot here. We want to package it for deployment, and we'll do other kinds of things. So we used to set a lot of this up using build features inside TeamCity. So there'll be like an NUnit plugin and an XUnit plugin and that kind of stuff. And we do use all these different plugins to do all this kind of work on the build server. And that was fine until we realized that, very often we don't know if we're going to break the build before we push the code, because it's actually pretty difficult to recreate what's happening in TeamCity locally on our local machines. And someone recently tweeted this, saying that really what's missing from this experience is recreating things locally. If you can recreate your end-to-end pipeline locally, it saves you from this kind of like, I don't know if you've been in this situation before, where you push the code and you wait 20 minutes for the build to break, you have a coffee, and then it breaks, so you try something else, you push the code again. And I've often found I've got a sort of train of commits going, fix the build, fix the build, fix the build, fix the build. I see people smiling. I guess you've seen that a few times. It's funny when it happens. Hopefully you end up squashing it's on the branch, you end up squashing the commits together on something. But it's a real-time suck, And what we really wanted was a reliable, reproducible way to reproduce what's happening on the build server locally on our machines. So we looked to writing build scripts, right? Can we write a script to do this build and run the same script locally as we run remotely? And we looked around for what is there that allows you to build scripts, to write build scripts. And there happens to be a relatively new kid on the block, right, from 1976, called Make, which is part of the standard Git tooling. And again, because I'm on a Mac, which is Unix-like, it has Make on it. I didn't have to actually install it, it actually came with it. So I should be able to show you that running. Okay, this is a very, very simple Make file. So let's examine what this is for a moment. So what we do in the Make file is we define a series of targets. And here we're defining a target called build. And in here, we can actually do whatever we like. You can write any shell command you like inside a target. This is a very simple example. All I'm doing is a .NET build, and then I'm defining another target called test. That target depends on build. Okay, so if I run test, I'm telling Make that I need to run build first. And then I'm doing a .NET test, and I'm saying no build because I've already built it up here. Okay, it's a very, very trivial example and not something you necessarily need, but I just want to show you the structure of how to write targets. And then we're saying that the default goal, if I specify, I don't know why it's goal and not, I don't know why it's goal and not target, but we're saying the default is test. So if I don't specify which target to run, I'm going to run test. So then if I run Make, then what I should see is we see the test running here, but because build is a dependency of test, we run build first. Okay, and if I want to run a specific target, I can run make build. That'll only run the build. It's pretty simple. That's all fine, but at this time I was working in a very heavily Windows-based environment. We didn't have Unix available to us. We didn't have a Unix-like operating system available to us, so we didn't have Make on Windows. So we looked to what is there that's provided to build or to write build scripts for .NET projects. Happens to be something called MS Build, right, provided by Microsoft. And MS Build, you can actually write an MS Build file in XML, which is a little bit verbose. And yes, you have this kind of like namespace stuff up here and obviously your elements and things, but it's actually very similar to what we saw in Make. So if I split this over here, we can actually see it's very much the equivalent, right? We're defining a target called build. We're saying exec is a target which allows you to run any kind of shell command. We're running the .NET build. We're saying test depends on build. We're running the same command here. And we're saying the default target is test, right? It's almost exactly the same. So what we can do now is we can actually execute this, and we can say .NET MS build, build.xml, and we should see everything running again. And yes, it works. And we've got other options available to us. We can do things like increase the verbosity of the output, so you get nice comments to say the build is running here, the test is running here, the default targets are running here. You can do other things like list the targets. I think it's TS. Yeah, you can list the targets available. You can run a specific target. The syntax is a bit awkward, but I think it's that, just to run the build. So it works very much like Make, which is all great. But of course, yes, it is XML. And try writing code in XML. I challenge you. We did use this for quite a while. I think we spent about a year writing MS Build project files in this way. But after a while, we found ourselves spending days, if not weeks, trying to do really basic operations in XML, in the MS Build XML, like string operations, looping over things. It's really just not trivial. When MS Build was open source, someone actually sent a pull request to replace it with Make as a joke, which is it's actually someone who's at this conference. I challenge you to find out who. But anyway, we decided that MS Build was only getting us so far. We really wanted to write something. We really wanted to write some our build scripts in a much more flexible language. At this time, Rake was very popular. Okay, Rake is basically a Ruby version of Make. And it's very similar to the make file. Okay, now this is actually Ruby. This is full Ruby code here. This do end is basically like a lambda in .NET. It's just like an arbitrary action. So the syntax is similar. They call it task instead of target, and you actually have to say task explicitly. Again, we've got a build target. sh is a rake function which just runs a shell command. And it's exactly the same. Test depends on build. Test does the same, and the default target depends on test. So again, we can do rake build for a specific target. We can do just rake to build both. We can list the targets like that. It's very similar to make. So we love this because now we have the full power of Ruby as C# developers. Kind of worked okay for a while, right? But then our build scripts, and again, you know, I'm showing you really simple examples here, but our build scripts were getting pretty big, right? And there was some non-trivial Ruby going on in there. And Ruby is an incredibly powerful language. I don't know if you've ever used it, but it's great. It's quite terse. It's nice for scripting. And it was really weird when we had a new person join the team, and we said, "All right, you need to build our .NET project. The first thing you do, install Ruby." It's like, what? You know, so it just had a bit of friction associated with it. So we started to think, well, what else can we use instead of this? You know, wouldn't it be nice if we could write our build scripts in C# or in some .NET language? So we looked around and we thought, well, there's something called psake, which I think is supposed to pronounce Saki, I'm not sure, which is in PowerShell, but again, that's another language. There was Fake in F#. There were some other things available. There's actually some things that I created, which use C# scripting, but that was a bit Wild West. If you wanted to debug a C# script, you're kind of on your own, and you know, the tooling wasn't really first class. So what I thought was, wouldn't it be nice just to be able to write stuff in a regular console app, right? Just a regular C# console app. And now the thing is, this in modern day .NET is a valid C# console app, right? That is executable. That is compilable and executable, right? It's a shame that I still need the CSproj file. The thing is that these two things I think can be defaulted. They could be inferred because, you know, ultimately I am running .NET 7. So why not just default to the current version that I'm running? Why do I have to specify it instead of unless I want something else? And if I'm running a program to CS, that's already inferring an entry point, right? So why do I have to specify exe? You know, I think we can actually get rid of the CSproj, and we should be able to just run a program.cs directly. You know, it'd be nice. But at the moment, we still have a CSproj. But that's not a huge price to pay, I think. But we can run this directly. We can do .NET run, and we have to specify the project because that still exists, and targets, and that should just work. There we are, our hello world. Great. So we've got a way of effectively writing scripts in C#. What I need now is a way to define some targets. So what I did was, with reference to what I do in something like Make or Rake, I actually did this. I wrote the syntax which I would like to have. Okay, so I wrote targets. I thought the easiest way to do this would be to just call a method. I mean, you could, oops, I don't want that. You could define classes and things, but I think the simplest possible thing you can do is to call a method. So I want to define a target called build, and I want to pass a lambda to that, just an arbitrary action to do something. I'll leave aside invoking .NET build for now. I'll come to that in a second. For now, I'll just simulate it. I'll just say I'm building. Okay, just as a simulation. And that should work. And then I want to define my test target. Oops, so I want test, and I want that to depend on build. Now, I don't want to be able to depend just on one target. I want to be able to depend on more than one target if I want to. So I actually want an array here. So you have to use this rather cumbersome array syntax in C# to create a new array. And then I want to do something like, yeah, I'm just simulating that I'm testing. And then I want to define that default target. And I want that to depend on. Now, at this point, I didn't really want to have to repeat this this syntax here. It's a shame we can't define a literal array a little bit more simply in C#. If you're coming from something like Python, you've seen much nicer ways of doing that. I decided it'd be nicer to have something like a depends method to say, and this makes it really explicit, right? Because you can just read that syntax and say it depends on that. And you can make this a parameter method, so you can take more than one string. And that allows me to write depends on test with no, I'm missing a quote here. And that doesn't have any action, it's just an empty target which depends on test. Cool, so that's the syntax that I want in C#. That's the simplest possible thing that I want in order to define targets in C#. So what I did then was I went ahead and just implemented that in a library. So I can install that now, and if I do .NET add targets package, and I called it Bullseye, inspired by the word target. And if we look at target csproj now, it's included a reference to Bullseye. Obviously, we get rid of the csproj, we need a way to declare dependencies in the CS file instead, which I'm sure is doable. And now if I've done everything right, oh yes, so Bullseye is just a library, okay? So here I'm calling methods to define targets. Because it's a library and not some kind of runner, I need to actually invoke the library in order to run the targets. So I do that by doing something like, oh yeah, so if I introduce Bullseye into the usings, so Bullseye targets, you see that, there should be target, not targets. That now lights up, that's now a call to Bullseye, and I do run targets and exit async, and I can pass the arguments passed into the console app. And because it's async, I do an await, and if I've done everything correctly, I should be able to do .NET run projects targets and no project, and it runs. Okay, so we can see that we are building here, we are testing here, and we get some nice output. I did some work into the output to give you a nice little summary of which targets run. So that's all fine. We've now got the building block for creating a target dependency graph. What we need to do now is to actually run .NET build. Okay, now you can do this in .NET, obviously. You can run an external process in .NET. And the way you do that is this. So first of all, let's make that into a block body. You can do process equals process start, and you can say .NET and build. Oops, Copilot's being too helpful here. We can do build. Then you have to do process.wait for exit. Then you have to do if process exit code is not 0, so if it's errored, you have to throw some kind of exception. Something like process failed. Oh yeah, we can do that. Thank you, that's nice. And now, if I've done everything correctly, there's something too much. Yes, thank you very much. And now that I hopefully have done everything correctly, I can now do, I don't really want to run, I don't want to type this command every time. So what I usually do is I wrap this in an SH file, which all it does is it just wraps that command. Don't worry about this is Unixy stuff, you can look it up if you want to. And it passes through the arguments through to the program itself. So that allows me to do, instead of that, I can do build.sh, and if I've done everything correctly, hopefully, yes, we now actually get our project being built. Now we want to do the same thing for the tests. Then the thing is, we don't want to repeat all of this code in here, so I'm going to pull it out into a method like that. Let's just call that something like run. We can convert this back to an expression. We can get rid of that. That's redundant. We can get rid of that. And we want to make this reusable inside the test target, so we can actually parameterize this here. And VS Code refactoring is actually pretty good now. You can do introduce parameter like that, and you can do introduce parameter on this one. Then we've got .NET build, and now we can lift that down to here, and we can do .NET test, no build, and hopefully, if I've done everything right, we now do a build, we should get our build and our test working. Okay, so it all works. Now, I don't want to have to carry around this method everywhere, this run method here. So I actually did wrap that up in the library, and I called that, let me just show you, add targets package, and I called that simple exec. Okay, now we get a reference to simple exec here, and what I should be able to do now is remove that method. I can now pull in a reference to simple exec.command like that, and that now lights up as a call to simple exec. So again, you know, I wrote the interface that I wanted and then just implemented it in the library. Now you might be asking, well, is it really worth implementing an entire package just for that little method? Well, if it was just that little method, I'd probably say no. But there are a whole bunch of options here, and these are options that are just passed through to system.process. Some of the options that system process has are they only work on Windows, so I didn't bother including those. I wanted it to be cross-platform. And there are other things like if you run something like yarn here or npm or something, it doesn't just work on Windows, right? On Unix-like systems, npm is a file called npm. On Windows, it's npm.cmd. And if you pass an npm.cmd file to system.process where that's on the path, it doesn't resolve it correctly, right? It doesn't work like it does in the command line. So I have to do all kinds of things within simple exec. So inside simple exec is quite a lot of complexity, even though the outside is simple. So it does all that for you. It makes Windows behave like you think it should. So again, if I've done everything correctly, then I should be able to build again. And hopefully, yeah, so that's now running in simple exec. So I've now got the basic building blocks I need. There are some build systems which do other things for you. So for instance, instead of writing .NET test build, there are some other build systems which provide things like, I don't know, .NET test and things like that. And you can say in here, you know, no build equals true and things like that. I guess there's some level of personal preference involved here, but personally, I would always choose to do this rather than this. Right? I don't want a wrapper around the command. I'd rather take what I type in the command line and have it here directly and see what I see here is the same thing as around the command line. There's a number of reasons for that. First of all, if I look up the documentation for .NET test or any other command in the universe which I might want to run, I see the documentation for this, not this, right? It's another moving part in between me and the actual command, so it's another source of bugs. There might be feature lag. When a new flag gets introduced, you have to wait for the flag to be introduced here. And ultimately, I don't want to maintain hundreds, if not thousands of methods wrapping around various different command lines in Bullseye. So I think it's much simpler to just do this. It's a shame that I can't just do this, that I have to split it up. But that's because I just pass these things through to system.process and it wants the two different things separately. I could introduce parsing into simple exec where I parse out that bit there and split it, but the devil's in the detail. You know, it becomes complicated when you've got quotes and when you've got spaces and things. I just don't think it's worth it. So I'd rather just pay that and split it up into two things. But it's very, very close to what I write in the command line. So, given those two things, I now have all the building blocks I need to write a build script, right? I can define a target dependency graph, and I can run any command I like in here. I can pull in other packages to do other things if I want them to. This is just a console app, right? I've got the whole of NuGet available to me. I've got the whole of C# available to me. What else do I need? So versioning. So versioning's important, especially if you're rolling out different versions of software to different places and you want to make sure you're running the right version and you want to be able to see what version you're running. So one way to do that is in the project that you're building, you can say, so let's just build this again first, just to show you what happens. So I clean the cache, and if I build again, what I get here is by default, .NET assigns version 1 to anything you build. You can change that by including something called package version. Okay, fine, let's say 6. Where's that gone? Package version, and now if I build it, and I'll just run the build target this time, then I get version 6. And that's okay, so you can control your versioning in that way. You can source control your versioning. There's a couple of problems with that when you use it in practice. For one thing, unless you increment that version every time you commit, you're going to get the same version being produced commit after commit after commit after commit after commit, right? Which might not be ideal. Secondly, we used to sometimes tag a certain commit and build it and then realize, oh, we've forgotten to increment the version. So you commit another commit to increment the version, then you'd move the tag and that kind of stuff, and it just got messy. So we thought about what would we like to do if we could. So what we'd really like to be able to do is to say, we'd like to tag the current commit, right? So we tag it, let's say version 6, and then when we build it, we want version 6 to be spit out. So I built a package that does do that. I just basically implemented that thing that I wanted, and I can install that now into the project we're actually building. So this, that's like that. And it's called Minver for minimalistic versioning. And what we see now is this rather horrible thing injected into our CS proj. This is very, very verbose and actually not necessary. What you can do is you can miss out all these lines here and you can just write package private assets equals all. That basically does the same thing. There's an outstanding issue for the .NET SDK to do this instead. Whether they'll ever do that is unknown, but hopefully they will. And the reason this has to be done differently is because Minver is a development dependency. So what that means is when I install Minver into my project, when I package this project, Minver is not a runtime dependency. And that makes sense because you only need to version your product when you build it. Right? You build your product, the version gets baked in, and then you ship it. You don't need Minver anymore. Development dependency is actually a feature that I added to NuGet back in 2014, I think. So NuGet was always open source. So I sent them a pull request and I added this feature. But they decided to implement it with this private assets all thing in the current version, private assets. So once Minver is installed, all I do is build, right? So all I did was tag my repo and build, and it comes out with version 6. And if I commit, so let's just do a commit, so test, let's just allow empty because I'm actually changing anything. And if I tag it again as version 7, and if I build again, if I build again, I should get version 7, there we go. And if I commit again, what Minver will do is it will say, well, the last tag 7 isn't on the current commit. It was 1 commit ago, so it increments the version for you. And by default, it assumes you're working on next patch version. You can actually change that to assume you're working on next minor by default. It introduces a pre-release identifier of alpha. You can change that. That's just the default. And it says this is a 0th alpha. So you're not going to actually release this. This is just to make sure that that commit produces a newer version. And when you want to actually release that alpha, you can tag it as 7.0 alpha 1, right? First alpha you want to release, and then you can build, and then you end up with 7.0 alpha 1. And now if we commit again and build again, we've already got pre-release identifiers, so it doesn't need to add any, and it just says you're one above the last tag, right? This is what's called height. You're one above that last tag. And if we commit again, then you should see that height increase to 2, right? Which makes sense. We're now 2 commits above that last tag. So that's versioning sorted out, and then we actually need to build this thing. So what I tend to use now is GitHub Actions. Where's it gone? Over here. And GitHub Actions is really good because it allows you to actually source control your environment. Okay, so let's just have a look at what's going on here. We give a name to this workflow. We specify when it runs. So I want this to run when I push the master or main and I raise a pull request. We set some stuff for .NET to just suppress all that bump that comes out the first time you run .NET. This is actually an advanced minver option. You don't have to use it if you don't want to, but here we can actually inject build metadata into the version. And for GitHub Actions, if you take the run ID and the run attempt, that uniquely identifies a given run in GitHub Actions. So we can then trace back the version of the software back to the actual run in GitHub Actions. You can then specify a bunch of different OSs that you want to test on, so Mac OS, Ubuntu, and Windows. You can give this a name according to the which OS you're running. You can tell you want to run it on that OS. Then we actually set up .NET with the current version of .NET. And then we check out our code. And this thing here, by default, the checkout action only checks out the very last commit, the very last commit on the current branch. For Minver, we want to read through the history to get that last tag. So we need to check out all the commits. So fetch depth 0. 0 is actually a sentinel value here. It means all the commits, because 0 would mean nothing. 0 would mean you get nothing in your repo. So 0 just means all the commits. If you've got a massive history and that takes too long, and you're confident that the last tag is within 100 commits or something, you can change that to 100 to get the last 100 commits, whatever suits you. Now, all of that stuff up there is all to do with the environment. That's just telling GitHub Actions what environment you want to set up in order to run your build. The actual work is done in the build script. Okay, so we're running exactly the same thing remotely on that central server as we're running locally on our machine. And I do encourage you to do this. So I've seen some GitHub Actions which do a hell of a lot more here, and they actually set up other things and set up Docker containers and that kind of thing. You can do that in your build script, right? Make your build script do that, right? And you can, if you want to, run, if that takes too long every time you run locally, you can create a special CI target, which does some extra stuff, but you can still take that and run build.shci locally if you want to reproduce the entire build on your local machine. So, there we are. So those are the build tools that I use. They haven't been around for that long, and there are alternatives. You know, there are alternatives to all of these, but I do encourage you to have a look at them when you're evaluating what to use. What does it do? What is it trying to do? Is it trying to do one thing and do it well, like run a target dependency graph? Or is it trying to do other things like be a runner and be a debugger and have Visual Studio add-ins and things like that? You know, with Bullseye, I just rely on the built-in tools. You know, you can run Visual Studio and JetBrains Rider and all the rest of it, and VS Code to do your debugging. Simple exec, it's all I need for invoking shell scripts. There's actually a very good library called CLI wrap, which is like an advanced exec if you need some more advanced things. Minver, we used to use Git version. I don't know if anyone's seen Git version. Git version's very complex. It tries to use your branches and which branch you're on to work out which version you should be creating. It uses commit messages, it uses tags, it uses all kinds of things. We often found ourselves in the situation of, why is Git version assigning this version, right? And sometimes we just had to give up. We just couldn't work out why it was giving our software a certain version, because it was inferring things from branch names and all kinds of things. It was really complex. All we wanted was a way to version according to the last tag in the history. And that's all that Miniver does. So I've shown you my build chain and philosophy behind it, which is ultimately based on the philosophy which I believe underpins modern computing, that doing one thing and doing it well. I don't know if those tools, Bullseye, Simple Exec, and Miniver, are going to be around in 50 years, but who knows? You know, I guess it depends if .NET's going to be around in 50 years. So I hope you've enjoyed that, and I hope you enjoy the rest of the conference, and thank you very much.